In this video, we'll be learning about sets using the roster method. Let's start off with this problem. Write a set in roster method consisting of your three favorite fruits and label it with capital F. So, we have our set name right here. It's going to be set F. So, if we want to write our set out in roster method, it's going to be the set name, which is set F is equal to, and then we have our curly braces. Because roster method, essentially, you just have curly braces, and then in those curly braces are all your elements. So our elements are going to follow this criteria. It has to be our favorite fruits, and we need to have three of those. Now, your favorite fruit is not a fact. It's not a widely known fact. It's going to range from person to person. This is something that's subjective. So your three favorite fruits, you're going to get different answers when you ask anybody. So any answer is correct as long as it's your favorite fruit, and as long as you have three of them. So there's multiple answers for this question. But my three favorite fruits are going to be bananas, oranges, and apples. So that's essentially one of your possible answers. And like I said, it's going to range from person to person. There's multiple different correct answers you can get, but this would be my answer. So as long as it's a fruit, your elements are a fruit. Remember, your elements are what's in your set. As long as they're a fruit, the answer is correct. Now, for the second problem, it says write a set in roster method consisting of 4 types of office supplies commonly found on a desk and label it with capital O. So capital O is going to be our set name here, and we're going to have equals, and then we have our curly braces for our roster method, and then we have to list our elements. So our elements have to be types of office supplies, and we need to have 4 of these. So there is many office supplies, but we can only choose 4. So everybody's going to get different answers from you. So one of the answers can be a pencil is going to be our first element, and then a pen is going to be our second element. Third element is going to be an eraser. And finally, our last element is going to be a stapler. And then we do a closed curly brace, and this is going to be your answer right here. So this is one of the possible answers. As long as your elements are a type of office supply and you have 4 of them, it's correct. So for this third problem, it says write a set in roster method consisting of 3 different geometric shapes commonly studied in elementary geometry and label it with capital G. So G is going to be our set name. So we have G is equal to, then we have our curly brace, and we list our elements. So we have different geometric shapes commonly studied in elementary geometry. And we have to have 3 of those. So you might have a different answer from the person next to you. It's a subjective thing. And the first three I can think of is a triangle, a square, and then a circle. So that's one of your possible answers. So for this fourth problem, it says write a set in roster method consisting of 5 different musical instruments commonly found in an orchestra and label it with capital I. So capital I is going to be our set name. It's going to equal, and then we have our curly braces. And then our criteria for our elements is going to be different musical instruments commonly found in an orchestra. And we have to have 5 of those. So the first 5 I can think of is a trumpet, a trombone, a flute, and then I have percussion, and then finally I'll do clarinet. So that's one of the possible answers. So for this fifth problem, it says create a set and roster method consisting of all prime numbers between 10 and 30 and label it with capital P. So capital P is going to be our set name. We have equals, and we have our curly brace. So our criteria for our elements is going to be prime numbers between 10 and 30. So that's not including 10 and 30. It's just numbers in between 10 and 30. So you need to know what a prime number is. So a prime number is going to have only two factors. So it's going to be 1 and the number itself. So for example, let's start off with the first number that is in our range. So the first number is going to be 11. So it's going to have factors of 1 and the number itself, which is 11. And that's going to be our only two factors. We can't break down 11 any further than this. So 11 is a prime number. Now let's try 12, the next number. So when we try 12, we have 1 and 12. But we can break down 12 even further. We can break it into 2 times 6. So if you notice, this has more than two factors. It has 4. And if you can break down 6 even further, and you can get 3 times 2, so you have even more factors. So for a number to be prime, it has to have 1 and the number itself. It can't have anything else. So 12 is not going to be a prime number here. So the next number is 13. So 13, we have 1 times 13, which 13 you can't break down any further. There's no factors for 13. So 13 is going to be another prime number in our set. Next is 14. We have 1 times 14, but 14 we can break down into 2 times 7. So 14 is not going to be a prime number. Next is 15, which we have 1 times 15, but we can break down 15 into 3 times 5. So 15 is also not a prime number. Next is 16. So we have 1 times 16, but we can break down 16 into 2 times 8. So 16 is not a prime number. The next number is 17. So we have 1 times 17, and we can't break down 17 any further. So 17 is going to be our next prime number. Our next number is going to be 18, and we have 1 times 18. And 18 we can break down into 2 times 9. So 18 is not going to be a prime number. Next is 19. So we have 1 times 19, but 19 we can't break down any further, so 19 is going to be our next prime number. Next we have 20. So 20 we have 1 times 20, and 20 we can break down into 2 times 10. So 20 is not a prime number. Next is 21. So we have 1 times 21, but 21 we can break down into 3 times 7. So 21 is not going to be a prime number. Next we have 22. So we have 1 times 22. But 22 we can break down into 2 times 11. So that's not a prime number. And then next we have 23. We have 1 times 23, which 23 we can't break down any further. So we have 23 in our set. And then next we have 24. So we have 1 times 24. And we can break down 24 into 2 times 12. So 24 is not a prime number. Next up we have 25. So we can break that into 1 times 25. But you can simplify 25 into 5 times 5. So 25 is not going to be a prime number. Next we have 26. So we have 1 times 26. And then we have 26. We can break it down to 2 times 13. So 26 is not going to be a prime number. Next we have 27. So we have 1 times 27. But 27 you can break it down into 3 times 9. So 27 is not a prime number. Next up we have 28. So we have 1 times 28, which 28 we can break down into 2 times 14. So 28 is not going to be a prime number. And then our last number is going to be 29, because we're not including 30. So 29, we have 1 times 29, and we can't break down 29 any further. So our last prime number in the set is going to be 29. And then we close the brace. So that's going to be your answer. So for this sixth problem, it says create a set and roster method consisting of all even numbers less than 20 and greater than 0 and label it with capital E. So capital E is going to be our set name here. And our criteria for our elements is going to be all even numbers less than 20 and greater than 0. So it didn't say greater than or equal to 0 or less than or equal to 20. So we're not going to include 0 and 20 in our set. So our next number is 1. So to determine if a number is even, you have to divide the number by 2. And if you get a whole number out of it, then the number is even. And if you don't, then it means the number is not even. So if we divide 1 by 2, we know that's going to give us just 1/2 or 0.5. So 1's not even. So the next number is 2. You can divide 2 by 2 and you'll get 1, which that's a whole number as a result of it getting divided by 2. So 2 is an even number. If we move to 3, you do 3 divided by 2, you're going to get 3/2 or 1.5. So 3 is not an even number. When we do 4, 4 divided by 2 is going to give you 2. So 4 is an even number. And then you'll notice a pattern. It's just every 2 numbers it's going to be even. So the next number is going to be 6, and then after that it's going to be 8, and then 10, and then 12, and then 14, then 16, and then finally 18. And then we close our set there. So that's going to be your answer for this problem. So for the seventh problem, it says write a set and roster method consisting of 3 playing cards from a standard deck and label it with capital D. So capital D is our set name, and our elements are going to be playing cards from a standard deck. And we have to have 3 of those. So they have 52 different cards in a standard deck, and we can only fit in 3, so we're going to get different answers. So it's like the problems that were at the start of the video. You're going to get different answers from person to person, so there's not just one correct answer, there's multiple. So the first 3 I can think of is 3 of hearts, king of clubs, and 2 of spades. And then we close our set. So that's going to be one of your possible answers. So for this last problem, it says create a set and roster method consisting of all odd numbers greater than 5 and less than 20 and label it with capital O. So capital O is going to be our set name here. And our elements are going to be odd numbers greater than 5 and less than 20. So an odd number is a number where you divide it by 2 and you do not get a whole number out of that division. So for our set, we can't contain 5 or 20 because it says numbers greater than 5 and less than 20, not numbers that are greater than or equal to 5 and less than or equal to 20. So we can't include 5 or 20 in this set. So we have to start off with 6. So when you divide 6 by 2, you're going to get 3. But remember, an odd number is whenever you divide it by 2 and you don't get a whole number. So 6 is not an odd number. If we do 7 divided by 2, we're going to get 7 halves, or 3.5. So that's not a whole number. So that makes it odd. So 7 is going to be our first element in our set. And then we move to 8. 8 divided by 2 is going to give you 4. So 8 is not an odd number. And we move to 9. 9 divided by 2 is going to give you 4.5, or 9 halves. So 9 is an odd number. And then we just move 2 numbers. So we have 9, and then we have 11, and then we have 13, then we have 15, then we have 17, and then we have 19. We don't include 20, and we don't go past 20. So we close our set here, and that's going to be your answer.